Good day, everyone. In today's discussion, we are going to solve all about angular momentum of three particles. But before that, let's take a look at this convention. Let's use iota for angular momentum, which is equal to the cross product of the position vector and the linear momentum, wherein our linear momentum is equal to mass times the velocity of the particle. Take note that the angular momentum is the cross product of position vector and linear momentum. Therefore, if we are going to know the direction, it is always perpendicular to the plane where R and P lies. For example, if R lies on X and P lies on Y, therefore the direction of the angular momentum is perpendicular to that plane. Therefore, it is here. So, it is always perpendicular to that plane. So, right hand rule is also important for that one. And to understand it further, let's solve for an example. Let's say we have this angular momentum of three particles. Referring to figure, determine the total angular momentum due to the three particles about the origin. So we have different particles here. We have particle 1, particle 2, and particle 3. And to solve this, let's solve first each individual particles. Let's solve for the angular momentum of each individual particles. And let's use this convention. Let's first solve for the angular momentum of particle 1, which is given by this equation. We have iota 1 is equal to the position vector 1 cross to linear momentum of that particle. First, let's solve for the position vector. As you can see here in the given, it is located at -2 in x direction and 1 meter in y direction. So we have this -2 in x direction, -2 meter I hat plus +1 meter in j hat. So that's the position vector. Now let's solve for the linear momentum, which is given by mass times velocity. So our mass, the mass of this particle is 2 kilogram, and its velocity is given by 4 meter per seconds j hat. So we have 4 meter per seconds j hat. Therefore, if we solve, we have 8 kilogram meter per seconds j hat. Now, to solve for its angular momentum, we do cross product of R1 to P1. So we can solve this by simply do the cross product. Let's cross R1 to P1. So first, let's cross -2 meter I to 8 kilogram meter per second j hat. So I cross j is k hat. So we have -2 times 8 is 60, -16. So we have now -16 kilogram meter square per seconds k hat. And if we do cross of j to j is 0. Therefore, our first angular momentum is this one. Now, let's solve for the angular momentum of particle 2, which is this one, as you can see here. This one. So we have 4 kilogram. First, let's use the convention iota 2 is equal to the position vector cross to linear momentum. First, let's solve for the position vector R2. As you can see here, the particle will be found in 4 meter at x direction and 1 meter in y direction. So we have 4 meter I hat plus 1 meter j hat. So that's the position vector. Now let's solve for the linear momentum. We have mass 4 kilogram and we have its velocity, which is 5 meter per second in I direction or I hat. So we have 5 meter per second I hat. So if we do calculations, we have 20 kilogram meter per second I hat. Now let's do the cross product of R2 and P2. So we can solve for the angular momentum. We have L2, which is equal to, if we do cross 4 meter I to 20 kilogram meter per second I hat, is 0. So we have no value. Now, if we do cross J to I, we have negative K. So, we have negative K. Therefore, if we multiply 20, 2 times 1 is 20 times negative K. So, we have negative 20K. So, we have negative 20. Then, copy the units. We have kilogram meter square per second K hat. So, that's our second angular momentum. Now, let's solve for the third angular momentum of that third particle. Let's have this convention. We have iota 3 is equal to position vector 3 cross to linear momentum. First, solve for the position vector R3, which is equal to this one. It is located 2 meter at x direction and negative 2 meter in y direction. So we have this one, we have 2 meter in I direction or in I hat in x direction, minus, since it is negative 2 meter j hat. Now let's solve for the linear momentum, which is equal to mass times velocity. Its mass is 1 kilogram and its velocity is 3 meter per second and its direction is I hat. Let's multiply. We have 3 kilogram meter per second I hat. Now let's do the cross product. Let's do cross L3 in order for that to solve for L3. Cross R3 to P3. So first, if we cross 2 meter I hat to 3 kilogram meter per second I hat, we got 0, so we have no value. Now let's solve for J hat. If we do cross product of J to I, we have negative K. Okay? So if we have negative K hat, then if we multiply negative 2 to 3, we have negative 6. So negative 6 times negative K is positive 6K. So we have 6 and copy the units. Kilogram meter square per second K hat. So that's our angular momentum for the third particle. And if we do final, and the final step, let's get the total of the angular momentum. So we have LT is equal to iota 1 plus iota 2 plus iota 3 equals to, we have negative 16 plus we have negative 20 plus we have 6, which is equal to negative 30 kilogram meter square per second. So that's the total angular momentum of the three particles about the origin. Thank you for listening. That's all. Hope you learned something. Thank you.